Okay, so let me share my screen. And then before that, I will show you how to bookmark. And I will show you how to bookmark. And it's easy. And most of the things that I'm going to be doing is through documentation. So I have many Google accounts. So let's click here. Let me go here. And I'll show you how to bookmark. So to have your bookmark synced to your account, you need to log in first. You need to log in on your Google account first. So to bookmark, what you need to do is come to this guy. Where is that bookmark? I don't think that guy is. So that doesn't really work here. So let me go to this my browser right here. So bookmarking is easy, right? So to bookmark, all you need to do is come, when you open your browser, you will see that you don't have anything right here. You won't have anything. So to bookmark, right click on this guy, and then it will say add a folder. I will add that folder and I will call that folder any name. So if you don't have anything Kubernetes, type Kubernetes in here. Let me say K8 right now. K8, and I'll save it. So mine is hidden. You should have your own playlist sitting here. So what you will do is that if we go to Kubernetes documentation, say kubernetes.io, and then you will just open the documentation right here. So you go to documentation. Let's say we want to start looking at something like, okay, let me say storage class. Storage. Let me just do storage. And I'll show you a way of getting that. So storage. So storage is right here. You see, I don't have it bookmarked yet. So how you can bookmark your stuff is click on this little star, and then you go select wherever you want that, which folder you want to bookmark this, and just click save in there. It stays in there. So if I go here, I will see that bookmark right here. So let me close my browser and bring it back up again. So I'll go to this guy, bring it back up here. So if I go to K8, it's always here. It wouldn't go anywhere. So tomorrow, if I come here and I don't want to go directly to my Kubernetes documentation, I just go to my bookmark folder, look for this guy, click it, and I'm back to my documentation, and then I will start doing things. So that's how I have bookmarked a whole bunch of things about Kubernetes in here, right? Sometimes I just need to go here and look for what I want. Then in this guy, I divided this into CKA, CKAD, and CKS. So you can see my CKAD, my CKS is here. So CKS is somewhere. Sometimes I mess with this a lot. Yeah, so that's how you do your bookmark, right? That keeps your documentation neat and cool. Before now, we used to use our bookmark to write Kubernetes exams, but they have created that environment in a virtual environment. Like, I don't know what kind of box it runs in, but when you log in, you can still open your Kubernetes documentation. And what they do is that if they give a question, let's say on a persistent volume claim, when discussing that question, they will embed the URL of that question on that documentation behind that question. That way, if you click on that, it takes you to a different browser. So you don't do bookmark anymore. So this kind of bookmark like this is just to help you do your stuff, locally. So that's how you do bookmark. Yeah. So that's how you do bookmark. Let me clean this up. Yes, so, okay, let's look at different ways of installing Kubernetes cluster. So I'll go to this document. Let me go to my bookmark and I see if I'll see anything. So before I go there, there are only two different methods of installing Kubernetes cluster. You either install your Kubernetes cluster on any cloud provider, or you bootstrap it using a self-managed style, okay? And then on the cloud, you have it running on AWS, GCP, Azure, and many other cloud platforms. So that kind of way of provisioning a Kubernetes cluster is called turnkey solution. And let me look for that documentation and send to you. I'll be posting documentation a lot on this thing. When I post it, bookmark it. They are called turnkey solution, turnkey ways of bootstrapping a Kubernetes cluster. And then other methods are manual. Okay, other methods are manual. You have things like kubespray, you have kubeadm, and then you have kubeadm, you have kops, AWS kops, you have Minikube, you have Kine. They are there. You have Kine. I will list them somewhere. So let me list them here. That way you can see it. So let me go here. So you have Kine, you have kubeadm. We'll be using kubeadm, and the reason why we want to use kubeadm is because it's the way the exam is set up, and it is very easy to understand. Very, very easy to understand. AWS kops, you have Minikube. So Minikube are just some sort of way of provisioning a sandbox cluster that you can use it, to test maybe a lightweight application. So if you have something that is heavy, that requires a whole lot of resources, that needs to run on multi-node cluster, Minikube will not really help you. With Kine runs as folders, right? And it will do the same as Minikube. But with Kine, there is a way you can configure Kine to run as multi-node cluster, but it will actually be running on your local machine. But you see a lot of node coming up. So that's how Kine supposed to to run kind of sandbox Kubernetes cluster locally.
Excuse me, I got a question. So what kind of application would you run on the Minikube and the one you want to run on the Minikube?
So if you want to test something like, okay, if you just want to test something like, let me say, okay, I'm not sure how familiar you guys are with some user data application like, sorry, user management application like Keycloak or something like JFrog Artifactory. So that's something that is a little bit heavy, okay? So if you're running it and it needs a lot of compute resource to run, because when you provision it, you need to do data persistence with persistent volume claim, okay? So what that means is that you will have to create a folder inside that Kine cluster that you are using. But then if the memory that you have assigned to your Kine cluster or Minikube cluster is not enough to support the folders that you want them to be created in that virtual machine, it's not going to run. Yeah, so it has to be a lightweight application, maybe just say like a front-end application that you have Dockerized it, containerized it, and then you want to see how you can orchestrate it. So Minikube will be very okay and kind to run that kind of things for you. Something like open policy agent, something like OPA, that you want to actually really install that application in it, create some policies to test, governance within your cluster. That is what Kine will help you for. But if you want to use it as a multi-tenant environment, like to run Argo CD, Keycloak, Apache Airflow, most of that thing now is not going to support those things. Those are heavy things. Yeah. So those are different kinds of way you can actually use to install a self-managed cluster. But the one that you can actually use to bootstrap a production-grade cluster, which I've not seen anybody recommended it, is kubeadm. You can use it to bootstrap a production-grade cluster. Another one I forgot was Rancher, right? We have Rancher. If you have time, look at Rancher. Yeah, you can use Rancher also to bootstrap Kubernetes cluster, right? So that's another way of doing it. So these turnkey solutions like this are certified. They are certified Kubernetes platform. You have AWS that leverages Elastic Kubernetes services. You have Alibaba, you have American Cloud, you have Microsoft Azure. You have a bunch of them right here, right? So on this platform, you actually have the third component of Kubernetes cluster, which is called the Cloud Controller Manager. So when we get to AWS or to Azure or to Google, which are some of the platforms that I kind of have a good understanding on how to bootstrap cluster on them, you will see how that cloud controller comes in and play a very big role in mapping some of your services to load balancing, helping you, just kind of route your traffic directly, and you don't have to install a third-party load balancing solution like MetaLB, right? When you really need to expose your application with a service type load balancer. So on the cloud environment, that is very easy to deal with, unlike on the on-prem where when you create a service, there is no way you can load balance that service. There is no way you can actually load balance it, except you deploy a bare metal Kubernetes or something like MetaLB to actually help you, provision some sort of IP addresses and load balancing. So we will see that. We will see it. So I have come up with a documentation that is very easy to use to install your Kubernetes cluster with kubeadm. Let me see. So I have come up with this documentation, and I'm going to go here and I say your repos, and I say this guy right here. So I'll copy this and send it to you guys. Just take a look at it, and when we go through it, you can go ahead and play with them. It's cool. I show how to quickly do it, like install your cluster with ease. Let me share this link. So who here still use what do you call it, batch, and what do you call the other things? Most of the things that I don't use it, I always forget about them.
GitHub.
What is that again?
GitHub. It's a good account.
No, this thing that you use to SSH to EC2 instance.
Body?
Yeah, Potty and something. Who here still use it?
Yeah, I still use Body and Mobile XM.
Yeah, today I'm going to show you a very easy way to access your any EC2 instance that you have on the public subnet. Easy with VS Code. Easy. So I'm going to show you how to do that today. It's easy. Okay, so without wasting our time, like I told you the last time, the only way I can take note and give to you is this guy. But I'm going to let me just go ahead and run and show you where you can get what you want. But then the last time I told you guys that a Kubernetes cluster runs on top of something that is called container runtime. When you hear about container runtime, don't only think about Docker. Yes, do not only think about Docker. So container runtime are actually different, right? They are different, and you can choose which one to use when you want to create your Kubernetes cluster. So there are many of them. There are so many container runtime. You have something like Docker. Docker doesn't. It's just that kubeadm doesn't support Docker again. I don't really know why, but all I know is it doesn't support it anymore. But something that has come in and most cloud providers are using now is Containerd, CryoCD, Mirantis, and so on and so forth. So if you want to kind of bootstrap your Kubernetes cluster with kubeadm, do not worry about using Docker anymore. Focus on using Containerd or any of those. So I will show you container runtime. Let me say CRI. So these are CRIs, and where are they? Yeah, they are there. They are there, right? I will look for them and give it to you guys later on. Okay, right here they are. So these container runtime are actually what will enable Kubernetes to run on. So, and the reason why they Kubernetes run on top of them is to be able to communicate with container registry. It could be Docker, it could be Harbor, it could be Nexus, it could be ECR, it could be ACR, it could be GCR. So that's what happened. So Kubernetes is absolutely very separate from Docker, but it cannot run without Docker or any container runtime. It used to, I don't know, it used to just be Docker, but according to this documentation, these are the recommended container runtime that you can use to you can use as container runtime interfaces on your Kubernetes cluster. So today we are going to be using Containerd as our container runtime. So if you really want to go in and find out how you can install each of these, you can click on any of those. So it will show you how to actually create these things, right? How you can create them in your operating system. So here, this is a documentation for Windows and Linux. Remember, I told you Linux is actually the best operating system. It doesn't matter what of Linux flavor you're using, whether it's Ubuntu, CentOS, and all of those things. So it will be the most recommended operating system when it comes to bootstrapping Kubernetes cluster of any form, whether you're doing it on the cloud in any cloud platform or you're doing it on-prem. So Linux is always recommended. So this is Miranti, I mean, Creo, I don't know what O stands for. This is how you can install them. You can actually configure them and use them when you want to, if you choose to use them when you're trying to bootstrap your cluster with kubeadm. So I have already prepared this documentation for you. So what I will do is that I'll copy this and put it in the chat. Just bookmark it, come back to it when you want to read further. So I'll put them here. Yeah, so here you can actually click on each of these and see what it takes to add them and so on and so forth. So let's go to Docker, right? Let's go to Docker. So Docker is here. Let me see. Even though it is stated that Docker is no longer supported, but there are so many things that you still need to, you still need to add to your local repository from the Docker documentation. Let me see that from this guy. So it doesn't seem to be here. So I don't want to waste your time because cluster installation takes a little bit long. So what you will do is that if you have your AWS account, it will be a good thing to do. So let's head up to AWS account, create some few EC2 instances, and then see how you can bootstrap a Kubernetes cluster with kubeadm. So I have my account up. Okay, I had already logged in earlier on. So I will go to EC2 instances and I'll go to EC2. My network is a little slower. Let me see if I'm on a different, if I'm using a different network. Because I have different network. See, okay, let's switch. Let me go to Oracle. That would be too far. Okay. So the thing is, there are some consideration that you need to take when you are bootstrapping your cluster, but I will show you that, but we're not going to go through that route because it takes a lot of configuration. Remember, our focus is just to know the basic way of managing, of creating Kubernetes cluster manually. Yes, but our main focus is to understand, is to dive in the cloud and do the real thing, practice some kind of GitOps, do some kind of continuous delivery, and so on and so forth. So what I'm just showing you here is to make sure that you understand the basic and the component of Kubernetes. So let's see about port here. There are some kind of port that you need to understand when you're creating cluster, right? So let me see if I have that right here. So these are them right here. So when you are creating your Kubernetes cluster, you really have to take this into consideration, especially when it is a production cluster. So these are all the ports that you need to enable on the control plane. You need to enable all these things on the control plane. And then on the worker node, this is what you need to configure. But I'm not going to go ahead and be adding each of these ports on the security group. What I will do is that I will just open all TCP ports on our security group. That way it has all of these ports. So remember in your exam, I think this question used to come, which is the IP range, the port range for the XCD server. This one is always there for your Kube API server. When we bootstrap our cluster, I will show you how the Kube API server endpoint looks like, and you'll see this this port number right there. So I will put this in the chat as well. That way you have in mind what is needed what kind of port you need to allow or disallow on your security group when you're bootstrapping your cluster. So I'm in the Ohio region, and I will say launch. So our goal today is to launch a 3-node Kubernetes cluster. We'll have 2 for worker node and 1 for control plane. So here I'll just call it K8, but I will rename it later on. Now I will choose Ubuntu as my operating system. I'll not use 22. I'll go use 20. My internet is unstable, really. So I'll use 20 right here. Stay tuned if this thing kicks me out. Now, one thing you need to know is that when you are bootstrapping your cluster, your control plane needs to have at least 2 CPU and 4 gigabytes of RAM. So I'm just going to take something like T2 extra large. I don't care. I don't really care about this because I'm going to shut it down in a way. Let me choose something a little more than this. T2 extra large. I don't want to come back for memory. And then we need to select the key pair. Do I have any key pair? No. Now let me create that key pair first. Call that key pair K8 key pair. So I need it in a PEM format. I'll create my key pair, and it's downloaded. So I'll use that key pair for all my nodes. And then I'm going to see if I have any existing security group that I can use. Let me use this, my Chatterbox security group. I will fix that later. So for networking, just make sure that your EC2 instances are run on the public subnet. That way you can actually SSH into it. So once I see here auto assign public IP address is enabled, I don't really care because I know that it will actually support a public IP address. So what I want to do is, if you care, you can increase your disk size. Let me increase my disk size to 50. That's how I do it for my local cluster. And I'll click launch to launch my cluster. So that should launch my cluster, and I'll go back to instances. Did it create 3 clusters? Why only 2? Should be 3 now. So I'm going to go ahead and do it again. Okay. Do it again. In here, I'll just call it worker. Worker-2. I'll do same thing for the operating system. You can add if you like, you can add anything apart from Windows. I just like Ubuntu servers because they are easy to go. I just like those things. Put here. Let me go with. My network is jumping. Go with this one. Select. And where is this one again? Security groups, Chatterbox. And I'll boost this guy to 50. I will do launch. I'm not sure what network is in, but that's fine. I guess it should have public IP. So let me show you how you can easily connect to your EC2 instances using, what do you call it again? Microsoft Visual Studio without any problem. Master, I will save. And then in here, I'll call this worker bash 0. So is that it? No, let me rename this one. Okay, so we are in the EC2 instances creation phase. Follow that naming convention. Okay, so that is it. So now let's go and adjust our security group. Remember, I told you about this port thing. So what I'm going to do is that I will use all TCP port and it will apply to this. But if you really want to narrow it down to each port, you have to, all you need to do is that you need to create each of those instances in its own security group. They have to be in their own security group, but that's a long process to go. And I don't want to go through that route because it's not necessary. So let's go fix the security group and make sure port. Okay, the port is open right here. All the TCP ports are open, and edit inbound rule. They are open, and port 22 is open to my public IP address, and you can see that all TCP ports are also open to my public IP address, and that's how you want to do it. Now let's go ahead and connect to our Virtual Studio. So I will do VS Code, open that. So there are some plugins that if you don't have, you need to install those plugins to actually help you connect to your EC2 instance in a very easy way. So, and I'll show you those plugins. So open your VS Code, go and click on this little 4 square button. Click on that and type here remote. Sorry, and type remote SSH. If your network is faster, you see this plugin right here comes up. So click on that and install it. The next plugin you should look at is remote development. This next plugin. Click on that and install it. So once these 2 plugins are installed, you should see this little 4 square thing come up. I mean, the server icon comes up. It should appear here. If it doesn't appear, close your VS Code and open it again. So once your VS Code is closed and reopened, in here, you will see Remote Explorer. You need to be on that little icon. You will see Remote Explorer. And then click here and you will see different things. I have so many things configured here. Say I have my dev container. I could SSH to a Docker container. You will see Windows subsystem for Linux target, and then you see remote. Be on remote, okay? When you are on remote, you will see all these things right here. Maybe your own will just be like this. If you click on the drop-down button, you will not see any server. So it will be like this. So the way you configure it is click on this little wheel setting button. And then the first thing is should be your user.ssh and so on. If you don't have that .ssh, create it. Maybe by installing the plugin, it automatically creates this .ssh folder for you. So go in here and do this. This is very important. So pay attention to this. So let me say I have created 3 EC2 instances. So let me copy this. Let me copy this from here, right? I'll copy this guy, just come here, paste it. I'll paste it 3 times.
So the first plugin is Remote SSH. What's the name of the second?
Okay, the first plugin is Remote SSH. The second plugin is Remote Development.
Development.
Yes.
Okay.
Remote SSH, then Remote Development.
Thank you.
You're welcome. Now, we have 3 EC2 instances created. We have master. I'll call this host. The host is the name of the server. I'll call it master. And then I'll call this guy worker1. Then I'll call this other guy worker2, right? I'll call it like that. And then here, this is how I do my stuff. This is how I do stuff. So I'll go back to terminal. Okay, I'll open a terminal. And on my terminal, this is where I have my key pair saved. Okay, I just have a key pair downloaded, created and downloaded. So that key pair was called Kubernetes K8 cluster key pair, and it is downloaded to my download folder. So this is where I have my key pair saved. My key pair is in CD desktop key pairs. This is where all my key pairs are. If I list it, you should see a bunch of key pairs. But the other guy was downloaded and saved in download folder. So I'm going to copy it to this directory. So I'll say copy, go back, download, have to go back again. Wait a minute. It's okay. So let me do this. Okay, it's not right. Okay. What's going on? CD download. Okay. So I'll say copy that K8. key pair that we just created. And I'll give a path where I want that key pair saved. What is happening to my computer today? Copy this now. Desktop. Key pair. I think I needed to press. Something is wrong with this computer today. Desktop. So I have my the K8 key pair right here. Okay, so where is it again? This one. Now, what I need to do is I need to put the path of this key pair to this directory. So I'm going to say pwd to get a path. So since I know that I'm on top of my window, you can still have this ampersand with a / to represent home directory and then whatever you are. So since these guys are in the same directory, I'm just going to remove them, copy my key pair right here, and paste them here. And I'll do same here because I'm using the same key pair to access all of these guys. Okay, and note the server name, username is Ubuntu. I will show you how to get that. So if I go back to the cloud, to all the EC2 instances, and I click on one of the servers, and I click on one of the servers, let's say, click on this and do connect. You should actually see that username is Ubuntu. So that's why I just left my username here as Ubuntu. Then for master one, I will go ahead and copy the IP address of master node. Just just select that, copy the IP address of master node, come here, put here. Do same for, no, that was worker node. I will switch that. This is worker one, right? I will copy the IP address of worker one and put on worker one. This was for worker two. Worker two. And this was for master. So I'll copy this guy, put it on master. So let's go ahead and test our connection. So when you do this, go back to this server icon and then refresh it. You should see that all your servers should come. So refresh it right here, right there. What is it telling me? The extension, turn it. No, I don't want to do it on GitHub. So I'm not seeing my servers. Okay, they are here, right? Master one, master, worker one, worker two. So let me connect to master. So there is a way you can do that. I want to connect to each of these VS Code, right? So if you click right here, you open it directly to this Windows. But if you click on this little plus sign, it will open a new VS Code window for you. So I'll click on that. You open this brand new one for me. So let's see how it goes. So it tells me my operating system is Linux. I'll choose Linux. And then you'll see it here. If it is initializing VS Code, this is installing VS Code plugin in that server. If it does it successfully, it will install it. If it fails, it will fail. So that has failed. So I don't want to troubleshoot that. Let's go to the next one. If it fails, it fails. We'll use a different method. So if it doesn't work very well, you have to do it on your own and troubleshoot it. So this is actually going to fail because it's taking too much time. So let me see what is the problem. So K8, okay, so let me see something. CD, desktop, key, SSH-I. What is key pair name again? K8. K8. Ubuntu. Ubuntu at. Let me do this. Yeah, so if that doesn't work, that means there is a problem in that account, and I will switch. Yeah, I will switch. This I remember this account used to. I mean, this region used to give me headache. I'll go back to US East one. Maybe I have this for testing purposes. I'll stop it. Stop. Yeah, maybe my NAT is not working. I don't want to troubleshoot that. Yeah, my NAT is not working. That's the 3.
So why do you need a NAT for it to work? I thought it said it's on the public subnet.
Let me say, yeah, my NAT gateway, right? Maybe is wrongly configured. Sometimes I used to mess with those things. Maybe I messed it up. Maybe I remove it from the subnet that these things are attached to it. You know, that could be the reason why it's not coming up.
You use the default VPC or you use the...
Yes, I always use my default VPC because I don't want to. Let me see something. Let me increase this thing to 20 for both. May not go that much. So let's go. Yeah, that region, I even forgot that region doesn't work for me sometimes. Pending, running. Okay. So let me redefine this and call this master. Here it is. Call it 01. Call this 02. And then I'm going to get the IP of this guy. I'm afraid. I'm afraid I didn't pay attention to network. Okay, that's great. See, this is not right. Something is wrong. Something, okay, that's fine. Okay, that's fine. So I'm going to redefine these things. I'm going to put it here for master. It should work now. That region is a mess. Apache key pair. And I'll put the Apache key pair thing here for every EC2 instance. Should work. Okay, so I have this. Let me try this guy and see if it works. I'm not sure what subnet I used. Continue. Yeah, that is connected for worker one, for master. So I will open a terminal here and do this. So that is my terminal. I am in that EC2 instance within VS Code. I can run code in here as if I'm running code on my local machine. So what I'm going to do is I'm going to rename the host name. So I'll do sudo hostname ctl set hostname master. You can set your own control name, control plane or master, but I'm going to set my own as master. So what did you say? Sudo hostname ctl. So I'll quit and open a terminal again. You should see my hostname has changed to master. So that is a master right there. And in here, you can see that this is master. I'm connected to master. So I'll take my browser down and then I'll go and get the IP address of the worker node, come and paste them there and do the same thing. For worker one, I'll get the IP address, which is a public IP address. And I'll get in here, paste them here, save, and then open another browser, not a browser, another VS Code window for that. I'm on a Linux server and come on, don't fail me. I don't think it's wrong. Okay. I'm just going to actually. Let me try again. Okay, so let's go again. Okay, now it's open. So I will open a terminal. Open a terminal. Okay, do sudo hostname ctl set hostname worker --01. Do exit and then exit again, and then open another terminal. So let's keep this guy aside. And then go set IP address of this guy again. Click on this. Get its own IP address. It's kind of weird. That's it here. Save. And then I will just open it on this window since it's the last instance. Linux, yes. Yes. Okay, the guy is downloading. Nice. So I'll open a terminal. Open a terminal. Sudo hostname ctl set hostname worker --2. Okay, so we now have our 3 virtual machines and we are ready to install our cluster. So let's go to master node. Where is the master guy? let's go to master node and start the installation. Master. Okay. Let's go to master and start the installation. I'll keep this on the side, and then I'll keep the documentation on the other side. But this guy is going to disturb me a little bit. So let's go to this documentation that I have it set up on GitHub repository. I have already given you the URL of this GitHub. It is a public repository. You can clone it and save it locally to have this script. So in that root directory, you should have something in there called script. In the script, let's go to manual installation. So you will see all of these things that I have set here with steps. And these steps, the step will tell you what we are doing. Like the first thing is to update packages and set IP tables. So you copy all of this, and paste in the browser. I mean, on your command line. It will install all those things for you. The next thing is we are going to do is to verify the IP tables. I mean, the IP module. Copy that. Hit enter. Hit enter right here. Then update the package again and install certificate code and whatever that is. Copy this. The next thing you do is set your IP table again. Let's disable swap. On Ubuntu, if you are using Ubuntu server, you must disable swap. If you don't disable swap, your kubelet will not run. I have been in that problem. But if you are using any other Linux operating system, that's okay. So you have to, clone your runtime repository. So that will contain containerd. If it was Docker, after setting up this repository, you can install Docker, CryoCTL, and all of those things. So, but since we are interested in using containerd as our runtime, we will install runtime after putting this repository locally. So let me clone that and then install this guy. Come on. Okay, now, so what's going on? So it takes a minute for the runtime to get installed. Let's check if it is running. Let me check if it is running. You can run this thing as a script, and I'll show you how to do that. I've already prepared that script. So containerd is running. I will quit. Now, this is the fun side, the fun part of it. What this means is that there is this part of it that says configure containerd to use C group. Containerd doesn't use C group when it comes to when you install it. And if you don't configure it to point everything like I don't know if you have ever used Docker Swarm or all of those things. It used to be that for Docker to run, to be able to persist data or create volumes, you need to really actually configure that to use whatever C group they used to be Jonah-DL and C group. So that's the same thing you need to do for containerd to be able to actually, use the socket, create storage if you really want to persist data on your local machine. When we'll be using persistent volume claim and persistent volume, I will show you how that actually happened on the node that a port gets scheduled. So it's actually a folder when you're talking about volume and so on and so forth. So let's go to this directory and set up this configuration. So I'm going to remove everything in this folder according to the documentation. What I'm interested in adding in this is this guy. I'll add that. If you don't know how to use Vim, you can use Nano. Nano is easy to use anyway. Then let's download our Kubernetes. And so what this repository consists is kubeadm, kubelet, Asper, kubelet, Romley, and kubectl. So when these are the dependencies, everything that you need to use to bootstrap your clusters. So this is what this last part is. So when you clone this locally, it will consist all the versions of kubectl and so on and so forth. But here, Kubernetes, the current Kubernetes version is 1.17, but I have decided to choose 1.25 because when we'll be doing cluster upgrade, you'll see how you can move from one version to the other one. That is the reason why I specifically choose this one. So let's install kubectl and other dependencies. So once this is running here, let's go and actually configure and install all this in the other node. We are not going to do it manually so that we don't waste our time. So I'll show you how you can run that as a script to actually bring all those things up at the same time. So in here, in this script, you still have another file called install. So I'll copy this file. I'll copy the whole of this file. Or you do raw, you click on raw here, copy everything. I want to run this in the rest of the two servers as bash script. So I'll copy it right here. I'll go to this guy right here, which is node 02. So I will do COD and then I'll do install.sh. It will open this guy right here and I'll press it, save it. So if I do a list, you'll notice that this thing is not executable, but I'll make it executable. +X, and then I'll do install. So if I do a list again, now it becomes executable. I'll do sh, then I pass the file name and hit enter. You should install all those things for me. So at the blow, I should do the same thing for the other guy. Code. So you use code to open a file or a folder on VS Code only when VS Code plugins are installed. If VS Code plugins are not there, you will not be able to open a file or a folder with code. That's the simple way of opening a file. If you're not familiar with using any code editor like Nano or Vim or Pico or any of those things. So let's save this and make the file executable. You can actually still do sh. I think it will still run. Sh install. Yeah, it will still run. You don't have to really make it executable. So let's see if the other guy is done running. Yes, this guy is done running. So let me check. System sudo system cdr. What is that? Container D? No. Let me use service. Service container D status. My container ID is up and running. I will quit and check kubelet. see if my kubelet is running. Okay, so it's not seeing anything kubelet, right? So I will run the command again from this install. Go back again. I'll run the script again from manual install. And this is what I'm going to do. Kubelet is now running here. And I will do this again. See what is going on. Wait, let me check kubelet. Okay, kubelet doesn't really have to run because sometimes it doesn't run until you trigger the cluster. Yes, sometimes it doesn't. So that is it. And the next thing we're going to do is go to this node, to each of these worker nodes, and set up the C group again. So I will copy this, put it here, save it, and then do it again. No, that's the same place. No, that's master. Do it again here. Sudo vir xcd container d config. Then I'll get rid of all of these things. Paste this guy, save it, quit, and then restart my container D in all the nodes. Restart, and then where is the other guy? Feel free to ask your question if you have one. Now, since this is installed in all the nodes, I will focus on the master node for now. So let's see how everything goes. So we are installing Kubernetes cluster version, Kubernetes cluster with version 1.25. So how does that go?
I have a quick question.
Yes, sir.
Just want to find out if we are supposed to be following along with you, or there's something we have to do after.
No, watch and do it after. Watch and do it after.
Okay.
That will be the best way to do it. I'll upload this thing later. That way you can watch it and do it. So
yeah, I always prefer to follow and then do it later, because when you follow and do it, you kind of lost track.
yes, that's right. So there is a way you can set up your cluster, right? Like if you cannot have an IP address that you want to use. Remember there was a private IP address, which was basically the host name of this, but I changed this to master. So how you can see it is, you can go to your cluster and you will see a private IP address of this EC2 instance, which is this guy right here. Let me see, master node, which is this AWS thing. Can you pop up? Which is this private IP address. So that was what it is. So if I do, let me see, if I do if config, I know I'm not going to see anything. It's going to tell me to install some bullshit, but I will install this network tool. That way you can actually see what the IP address. There is something I want to show you here that you could see it maybe in the future. If you are running your own VM somewhere, you don't really need to do that, but on something like this, you see it. So you see that this IP address, will match the private IP address that we have right here. It should match, right? But unfortunately, I'm not seeing it matching. But however, when you create some EC2 instance, remember you will see two private IP address, but that could be the reason. But you see that this is somehow within this range. I'm not sure why this private IP address doesn't match what I have here. Yeah, I'm not particularly sure, but it should match. It should match for some reason. I'm not sure why it doesn't match. Okay, so that's the master node. And how we are going to bootstrap our cluster is by running sudo kubeadm init. And by doing that, we could advertise the IP addresses, like the main IP address. Like if you have, let's say your gateway that you want every worker node in the cluster to talk to. You don't actually want to use the IP address of the master node. You actually want to use a single IP address within your network that you want all that worker node to be able to talk to. You advertise your Kube API server through that IP address. But we're not doing that here because it's not going to work. Why? Because the host name, which is the IP address behind this worker node. Oh, this is master node. I'm in the wrong node. Yeah, I'm in the wrong node. Which is actually behind that worker node. It's not going to work because it's this private IP address. It's not anywhere accessible through internet. Right. So if I do if config, that should match this IP address right here. Yes, it matches the IP address that I was talking about earlier. I was in the wrong node. So that should match. But like I said, this is a private IP address. It's not going to work if you try to advertise it like the main IP address that is going to be reachable by every worker node in this subnet. It will not work because it's private. So let's bootstrap our cluster by running this sudo kube adm init. So that should bootstrap our cluster for us. It takes a little while to bootstrap the cluster, but let's see what happens. Sometimes it takes too long. So here it's telling us that we have Kubernetes version 1.1, no, 1.271 or 273. Yes, where is it? Where did I see that? Right here, that we have version 1.27.3, but we have decided to take 1.25.3. Yes, so this has initialized a Kubernetes cluster and we have all the components already created. And in here, you should read from here to here because this is very important. What it's telling us here is that your Kubernetes control plane has initialized successfully, okay? And then to start using your cluster, you need to run the following as a regular user. Do not run them as root because you may not be able to run kubectl as root. So let's run this one after the other. I'm making that directory and I'm pulling my kubeconfig file to this directory. And then I am making this directory executable. Okay, that is it. So this is the file that conceals your Kube API server configuration. I'm not going to mess with this. Let me add the worker node to the cluster, and then you can then see what is going on. I'll concatenate this file, show you the content, explain to you what is in there. Okay, but then if you have worker node that you want to add them to your cluster, it says here that you then can join any number of worker nodes by running the following on each as root. You must run them as root. So you need to grab this. This is your join command that you can actually use to add worker node on this cluster as root. So let me clear my screen and do kubectl CTL dash, get node dash wait. So in a Kubernetes, many Kubernetes resources that you use have their aliases. They have their aliases. So node normally is supposed to be written like this, but its alias is NO. Pod supposed to be written as PODS, but its alias is PO. So if I write this, I'm just creating an alias. I'm just using that alias to represent node. So this dash Y means, dash W means wait or watch, right? It will be watching my Kubernetes cluster. Anything that adds onto it is going to show that something is going on. I will come back to this guy and explain a little bit of something that is going on. So I'll go to my worker node. This is the worker number 1. It says run as root. So I'm going to type sudo and then I hit place this command. So if I hit enter, what happened? kubeadm is not installed in this guy, right? So let me go to my worker, number 2, number 1, and do sudo, hit enter. Paste this command and hit enter. So yeah, so kubeadm is not installed on this guy. So what I'm going to do is I will go back again here. So these are challenges that you actually face when you are installing your Kubernetes cluster. It will happen. So I will repeat this stage again to add them locally. And let me do this again to this guy. Add that repository. And then I will grab these guys. I don't know why it's telling me that kubeadm is not kubeadm. It's not installed. That should not be true, right?
So how does this work in a work environment? I mean, when you get to work, do you have to create this cluster every time you need to deploy maybe an application?
No.
Or it's already there, you just maintain it?
It's already there. This cluster is already there. If you don't
So
create
you don't have to do this like every time you want to work on.
No, you don't have to do it anytime, every time. This thing has been created by one engineer. And if you come on board when the engineer is gone, it's your responsibility to maintain the cluster.
So you might not even get to create one in months.
Yes.
Okay.
You may not even get to create one. Or if you have somebody like a DevOps engineer in the team who is infrastructure as code knowledgeable, it should be their job to create the cluster, not you. It's never your job to create those things. They do it, that's their job. So this guy is just now installing our kubeadm and kubectl. So I guess it's installed right
Prof,
here.
can we run it as root?
Run what?
Those commands to install kubeadm.
Yeah, that's what it says here. That to do it, you must run them as root. So I'm running it as root right now. So look at what it's doing. And if I go back to my control plane and look at the behavior of my control plane, see, it's watching. It's just watching. Within a few minutes, something should happen. Okay. Maybe this is not going to add, but let's see. You should add a note to it. Let's see. So it may not be able to add a node. Why? Because this IP address is public. That is my concern. I mean, it's private. That is my very first concern. It may not. Yes, it may not. So that would be my very first concern if this thing is hanging like this. And do you know what I would do here? Let me adjust something. So I'm going to go to my security group and open this security group right here. Okay, open this security group. I'm going to edit this inbound role. Where is it? Is this a brand new? Yeah, that is the reason why it's not adding it. That is the reason. So all TCP. That is the reason why that guy is not able to access. I'll say my IP. I'll change this. I will not change that because I don't want to mess with that. That's the reason why those worker nodes are not adding. So they should be able to add now. So let me go here again and do open all the TCP port. What's going on again? Can you open yourself? Master nodes, security. All the TCP port. Okay, let me leave it to the internet. Anyway, IP version 4 as well. Close it. Maybe my network is messed up. Let's see. Now it's adding. Now it has added. Now it has added. So on the master node, you should see that all those worker nodes have been added. So now you have 3 nodes, the master, 1 master and 2 worker nodes with the same name that we just used. So you see that the host name right here is what corresponds to this node. Okay, but then I can go ahead and just close these guys, and then I will focus only on this guy. So this is how you check your cluster status, your cluster version, and so on and so forth. So when you get to your environment, right? First thing, you are giving access to a Kubernetes cluster. The first thing you should ever do is to do kubectl get node -oy. So what this means is that you want to get the output of all your nodes in a very wider range. That's what that means. So this will give you the version of the cluster, the internal IP address of all your pod, of all your nodes, okay, of all your worker nodes, and then the operating system that they are using, and of course the kernel version and the container runtime. So we are using container D. That's the very first thing that you always need to do. Because guess what? Sometimes you run application on top of a Kubernetes cluster and that application doesn't ever come up. And the reason is that it may not be supporting the Kubernetes version that you are running on. I remember trying to build DoD BDP big data platform on the Kubernetes cluster that was still running 1.18, and that was 2022, maybe somewhere June of 2022, and they were still running 1.18. It was a no-go. There was no documentation for that Kubernetes cluster. Okay, so that is it. So what can somebody really tell me what is going on here? So if you look at this Kubernetes cluster, you see that the status is not ready, you see? Meaning that if I deploy an application to this cluster, it's not going to work. It's not going to be scheduled on any node. Never, it's not going to schedule because my Kubernetes cluster is not ready. So how do you see pods that are running, pods that come out of the box when you create your Kubernetes cluster? So you do kubectl. So let me create an alias of kubectl, okay? So I will do vi.bash rst. I'll hit enter, and then anywhere here, anywhere here, I will just create the alias for my kubectl. So I'll do I, and then I'll say alias. K should represent what? kubectl. And then let me put that in quotation as well. That way it will create that little thing. Then I'll say source dot bash RC. So if I do K now, it shows me kubectl. Instead of me writing kubectl all the time, I'm just going to do K port PO-A. So you want to see that some of my port are pending, they are in pending state. So remember, in our architecture, we talked about the Kube API server. You can see that Kube API server right here. You can see the XCD right here. You can see the scheduler right here. You can see the controller manager. So these 4 things, that's what's for your cluster. So if I open that little architecture again, you are seeing them right here. So let me make this go to the left, and this guy comes to the right. You can see that this guy is the XCD, which is the data store. And then you have the Kube API server, which is this guy, the gateway, the communication center. Then you have the controller manager, the guy that really controls every other component of the cluster. Then you have the scheduler, which schedule workload on, which schedule request or workload on the EC2, on the worker node. So we have created 3 Kubernetes cluster with 1 control plane. Here is the control plane where I am running my commands, and the 2 worker nodes, I have shut them down, I have closed them, because if I create anything here, it gets scheduled on them. So these are them, and they are here. So remember, in each of those nodes, we install kubeadm, kubelet, and kubectl. Okay, if I care, I should not install kubectl on my worker node, because I don't really need them on my worker node. All I need is kubeadm and kubelet, because kubelet is actually the client that communicate with my kube scheduler and my container registry. But then we have another thing. What about this core DNS and the kube proxy? Look at kube proxy here. Is a guy that enables communication between your Kubernetes cluster node and the port. Okay, they are right here and they are up and running. But you see that some of these core DNS port are in pending state. That's the reason why you can actually see that your entire cluster, anyway, your entire cluster is not ready. The entire cluster is not ready. It's not in a ready state. Even the port, some port are pending. That brings us to this CNI network container network interface, which is written here as plugin network. So you can use Flannel, you can use Weave, you can use Calico, you can use anything, right, to install it to enable to establish a smooth network communication between your cluster. So I'm going to show you how to get that done, and we are going to be using Calico to enable all the network interface within our cluster. So that's how you actually install a Kubernetes cluster with kubeadm. So before we do that, does anybody have any question? So let me actually do that, okay? And one main thing that you should do is to get your cluster status. So to get your cluster status, you have to do get CS. CS means cluster status. So that will show you if all your components are up and running. So here you can see that all the components are healthy. There is nothing that is not up and running. So let's go get our Flannel deployed. Say it again.
I have a question. So I know we are using EC2. So if we are using, for example, EKS,
yes,
we have to do the same installation, or some of those installations are managed by AWS?
Yes, that's a very good question. That is a very good question. So on EKS, when you want to create your cluster, you just go to EKS, okay, Elastic Container Service, and you just create a cluster. So when you create that cluster, the only thing that comes up is the control plane. It's only this guy right here is the control plane. That's the only thing that comes up. Any other thing has to be manually added, like the worker node and so on. And this worker node are added through a feature called node groups. So when you actually create a node group, you create what is called AWS auto scaling group. That way you can always scale up your node or down. So that is a difference. When you create your cluster on AWS, again, I said, you only create a control plane. And the control plane, instead of having four components, sorry, has 5. The feed one is Cloud Controller Manager, the one that provision, the one that make any other APIs calls to other AWS resources like S3 bucket, Elastic Load Balancer, Network Load Balancer, whatever thing you want to use. Okay, so that is how it happens. So and then one main difference is that, see, we have access to our Kube API, so to our control plane. Like I'm manipulating my control plane right here. You see, on AWS, you will not have it. When I will install the container network interface here, I will show you where all your components are sitting in this master node and how you can tweak it, how you can change something, and what you and you can change your certificate path. You can modify anything you want to modify, right? I will show you how to do that. So let's go here and install Calico to make our worker node come up. So this is Calico documentation right here. I have this set up already. So when you open Calico documentation, let me go to manifest, okay? I'll go to manifest first. Go to this manifest because it actually tells you that you're installing your Kubernetes cluster on-prem. This is what you need to really focus on. You are doing it on-prem. This on-prem means you are doing it is a self-managed cluster or on-prem. So you have to click on this manifest and copy this. I actually like to code this, save it somewhere. So let me code this and save it like here. So if I do ls, you should only see one file in here. So I'm going to open this while, and I'll open another. Let me not open it, but let me close one. I will split it. So let me do here split. And then here I will do kget node -w to watch. But then there is this my Calico plugin in here. So if you want to really see what is inside that calico.yaml file, you can do code calico.yaml file and take a look at it to see what is in here. This is the declarative, this is the declarative file of this Calico thing. Okay, it is a declarative thing. And I think this is custom resource definition. Any long thing like this is always a custom resource definition. Yes, it is. So you can see what is in here and so on and so forth. There is nothing fancy here. There is nothing fancy here. So what I will do is that I'll apply this file to against my Kube API server, and I'll actually.
What exactly does Calico do again?
Okay.
Set up the network?
Yes, it's set up, establish a smooth network. So you see these nodes are not ready, right? But as long as I apply this file, you see things will start coming up ready. Because when you install your cluster, they don't care. They are not responsible to choose which network interface you are going to use to establish your network within the cluster. You have to choose your own. Depending on your use case, you can choose Weave, You can choose Flannel, you can choose Calico, you can choose any other network plugin. That is the reason. And that's why we are using Calico to actually set up that network. Else, if we deploy anything that needs networking, it's not going to work. Okay. So I will apply that by doing kubectl apply. So sometimes initially, if you want to apply something like to create something on your cluster, in your cluster, initially, you need to use a command create, then do -f if it is a file, and then call that file name Calico. It's going to create all that component for us. You see, it has created it. But very soon you're going to see this guy, you're going to see the behavior of this worker node right here. It's going to be changing. The status is going to change from not ready to ready. It should change. See, the master node has become ready. The worker node, everything is ready now because of that container network interface that has been created. So earlier on, we look at the port, and the port were not, and some port were pending. So if we do again, kubectl get port -a to represent every port that is running in the cluster. You'll see that the port now are running, and they just started running 40 seconds ago. You see, so you have 3 ports running here, and these ports are actually daemon set that are running on each of these nodes to establish network. Meaning that if we add another node to this cluster, you will see Calico will create another port again on the new node. Okay, so that's how it actually works. So to check the status of our cluster, to make sure everything is running, you will check the core DNS or the kube system namespace if everything is running quite well in the kube system namespace. So to actually specify the namespace, you have to do kubectl in the namespace of kube system get port. Yes, everything is running. It is ready, the status is running, nothing has restarted, and then you are seeing the H. Okay. Now, to see if the node are ready, there is nothing wrong with the node. You kubectl get node -oy. Yes. If you don't want to mess everything, just do this. See, everything is up and running. Now, let's go and find out where the component of this cluster is actually sitting in the cluster, the 4 components. There is a directory in your community, in your master node, okay, which is called the control plane, where we are running kubectl command, our master node. So here you have, there is a directory called the etc. So if I do cd into this etc file, and then I do Kubernetes, I do a master, what is this again? Kubernetes, manifest, and then ls. You should see that. Let me do it dash. You should see that. You see that all the components are here, right? We've talked about the ECD, we've talked about the Kube API server, we've talked about the controller manager, and then we've talked about the scheduler. So you can actually go inside each of these and see what is going on. So let's pretend and go to Kube API server. I'll concatenate that and you'll see what is inside. So it's not going to let me do it as a regular user. So I'll have to run this. So you see that. So this is it, right? This is it. It shows you everywhere. Look at the IP address of the master node. That is you right there. So it advertised it through this IP address. You cannot change it once the cluster is up and running. Remember this, you cannot change this IP address. It's running how many replicas again? A replica of 1. You can scale it to something. But guess what? Remember, these things are running as static pod. If I delete the deployment, it's going to come back immediately. This is what you need to know. Like I said, the Kube API server, the controller manager, the XCD and the scheduler run as static pod. If you care, you can create a pod in this directory and restart your container D. You go back to your Kube API server or to your Kube system namespace, you will see that pod up and running. So that's what you should know. So all these things run as static pod. So I've been doing kubectl get pod. So if I do kubectl get deployments, a deployment has an alias of deploy. You see that we have only 2 deployments in the Kube system namespace, core DNS and the what do you call it again? Calico Kube controller. Those are them. So to see if everything is working, you see that it's one-on-one, up to date, and so on and so forth. This core DNS has 2 containers in the pod. So we can actually dig deeper to actually see the number of pods that are running, what each pod is doing, and so on and so forth. So now, Divine, I want to show you the Kube API server, like the file that actually communicate with each Kube API server, and I'm going to tweak it. You'll see that it's never going to work. So if you were paying attention, there was a folder that we created and we call it .kube, this folder. And inside this folder, we have a configuration file called kubeconfig. So if I concatenate that, you will see it right here. So let me get rid of this guy right here. So you will see this file right here. Okay, you see this file right here. So this file is right here. And my Kube API server, this is what is used to authenticate to my cluster. And this is the client certificate and the client key and whatever is using to authenticate. But then if I dare change anything, like if I go there, instead of saying card, I do VI, hit enter, then let me not use Vim, okay? Let me not use Vim. Let me quit. Let me do this code. Let me use VS Code to edit that. That way it will be easy for me to do it. So if I just come here and change this IP address and just put 5, look at this. I'm not going to be able to, what happened? 5. I'm not going to be able to authenticate to my cluster again. So if I make any API calls again to my cluster, it should not do any get or put request. So if I do kubectl get something, see, it fails. It's telling me that there is nothing like this. It's going to fail. So that is an exam thing, right? That you always have to know that Kube API server is authenticated through port 6443. It is an exam. So you go to a cluster, you will see that they have messed this Kube API server and you will have to fix this port number. So if I try to run that command again, it should authenticate me. Okay, that's how it works. That's the trick about it. So remember, this thing is running in my AWS environment. If I grab this thing, if you have kubectl installed on your local machine, and I send this thing to you, you should be able to authenticate to this cluster. Bear with me, okay? That is it in the. Okay, it's too long. It's too long. I cannot paste this. So if I copy this file and send it to you, you should be able to authenticate with that cluster. If I open all the endpoints, you should be able to communicate to my cluster. If you have kubectl, kube client installed locally. So that's basically how this thing works. But then let's try something. We have created a cluster here. Okay, if I do kubectl kube get storage class, get storage class. SC means storage class. I'm not going to be writing everything in full. Like I told you, every resource on Kubernetes have their aliases. So I'm not going to be doing kubectl get storage class. And some resources are namespaced, some are cluster-wide, okay? So we do not have any storage class created yet. I'm not going to deal with storage class now. That's a whole thing we're going to be doing when we are doing persistent volume and persistent volume claim. So the main purpose of Kubernetes is to do what is known as scaling, orchestration. That is to scale Dockerized application, because there is no way you can scale a single Docker container if you are running that application as a Docker container. There is never a day. But if you're using Kubernetes to orchestrate that Dockerized application, there is a possibility of scaling it from one container to many containers without affecting a running container. Then there are only two ways you can use to create container, to create an application on top of a Kubernetes cluster. Number one is a declarative way of doing it, and number two is an imperative way of doing it. An imperative format can be in a JSON or in YAML. But then I'm going to use a declarative way of doing it right here. That way you can actually see how I will create a deployment, create a service that will map to that deployment, and how we will actually access that thing on a browser. Okay. So how do you create an application with a declarative format? So it's very easy to do that. So I've created an alias of kubectl to be K. So I want to create a deployment. There is a difference between a way you create a deployment and a pod, and I'll create those things so that you see them. So I actually want to create an application with Nginx. Okay. So this is how you do it. So I will do kubectl create a deployment. So a deployment, you can create a deployment like this, right? But know that the alias of deployment is called deploy. Okay, I'll create a deployment. I'll call that the deployment name Nginx. Okay, let me say day 2. Okay, 02. Okay, and then I need to pass the image that will be used to run my application. Is that how you spell image? No. So the image name is Nginx. So you can use VisiBox, you can use, and if you are doing it this way, that image should be an open, it should be a public image, because if it is in a private repository, it's not going to work. So it is Nginx. And then I'm going to pass some sort of replicas that I want my application to have. Remember, if you are running it on top of Docker as a container, you can only run one container. But on top of Kubernetes, which is an orchestration tool, you can run as many replicas as you want. 1,000, 500, 2 replicas, 3 replicas. So I'm going to say I need replicas of 5 of that. No, let's scale it down to 3. Okay, and I'll hit enter. So kubectl create. So I have 3 dashes on my image. So I hit enter. It has created a deployment. So if I do kubectl get deployment. Now, this is what has happened, Divine. What has happened is that I have done a create. So what happened is that this is a cycle that took place. I will take 10 minutes of your time. This is what happened. A put request, which is a create, went through Kube API server, the file that I just showed you, and it went through the controller manager. The controller manager talked to the scheduler, and the scheduler scanned the cluster, and then told Kubelet that, okay, take this workload and place it on any of these nodes. So how do you see that? So if I do kubectl get deployment, if I do -OY, you're not going to see anything like where that port is scheduled and so on and so forth. So you're not going to see anything, right? It's just going to show us that. But then let's do it in the port, in its name, in the form of port. You actually see where that workload is scheduled. Now, we are running an application that has 3 replicas. So what happens? The kube scheduler has actually scanned the cluster, told Kubedel that, okay, this deployment has 3 replicas. Take 2 replicas and place it on worker node 1, worker node 1. So this is it, right? You see that 2 replicas are running on worker node 1, and another one is, and only one is running on worker node 2. So if you look at it, it's going to be 3. Okay. Now that is how it works. That's how that process works. As easy as that. Now we have our application running in the cluster. The question is, how do we actually access this application on the browser? That is the question. So we use what is called a service. A service is a network component that is used to map your application to the internet, okay? Or it can be within the cluster or out of the cluster. When we are going to be dealing with service, I will show you different types of service, what each type of service is doing, and why it's used for that purpose. So we created a deployment, an application called deployment. That is it. And I want to actually make us access this deployment on the browser, right? So it's available, everything is up and running. So you need to use a service. So I'll say kubectl expose. You use the word expose to expose an application. I'm going to expose that deployment called day2. Expose a deployment called day2. And I need to give the service name as day2 deployment, day2, let me say day2 service, okay? SVC is a short way of representing a service in a Kubernetes cluster. So what am I doing? I'll have to pass the port. Don't worry about this imperative way of doing it. I know it's sometimes very difficult to understand it, but when I'll show you the YAML file of all of these things, you will understand it. You cannot even understand it now because we will start talking about selectors, match labels, and all of those things. You will understand what I'm doing here. So this is just a kind of a way to show you how you can actually expose your application on the internet. So I'm actually going to talk about a target port that I want to expose this application. My target port is going to be 80, and my port also is going to be 80. That's the default port of Nginx. But what type of service am I creating? I'm creating, my type of service is node port. Yes, is that how you spell node port? Node port. So I'll hit enter. That has been created. So if I do kubectl get service, get service, you can see that a service has been created. Okay, a service has been created called day2 service, and the type is node port, and then it's exposed on port number this. So if I actually do get service and I pass that day2 day2.o svc -o YAML, you can actually see that it has some match labels set to it, which is my deployment name is day2 deployment, and so on and so forth. I will explain this to you. It's not a load balancing type of service. So if I get this, the node port of that node, of that service, which is this guy right here, then go to my AWS. Since we verified earlier on and found out that our port are scheduled on all the 2 worker nodes, what I'm going to do is just get the IP address of any of my worker nodes because my port are scheduled on those 2 nodes. So I'll get the IP address of any of my worker node, and I'll come to my browser, put it there, and then I'll put the node port. That port is open on the node, okay? I'll put the the IP address of my node pod. I can close this guy right here. I can close this guy. I don't need them anymore. So I'll copy this node pod. In my browser, I'll put enter, colon, enter. So my Nginx should actually come up. What happened? So let's see something. Okay, so let's try this. Let's try this. Okay, I know why. I know why that is happening like that. So let me pick this again. So normally my Nginx application should come up, but unfortunately it's not coming up. But if we look at our security group, we have all our security group open to all TCP, and that port is within that range, but unfortunately it's not coming. So that gives us another advantage to troubleshoot that and get experience. So that is not actually coming up. So I will find out why it's not coming up, and then we can discuss that next class. Does anybody have any question? Does anybody have any question? Okay, so I will stop sharing, and then I will give you some guide on what we are going to do